Albert Einstein, a name synonymous with genius, a physicist whose theories changed our understanding of the universe forever. But who was the man behind the equations?
In the next 10 minutes, we'll explore his life, his groundbreaking work, and his lasting impact on humanity. Because Einstein didn't just change physics, he changed how we see reality itself.
Albert Einstein was born on March 14, 1879 in Ulm, Germany. Contrary to popular belief, he never failed math, but he did struggle with the rigid structure of formal education. One defining childhood moment came when he received a compass. The invisible forces moving the needle fascinated him, sparking a lifelong curiosity about the unseen laws of nature. And despite his intelligence, Einstein often clashed with teachers. He preferred independent thinking over memorization, a trait that would later define his genius.
Most people assume Einstein immediately became a professor. Nope. After graduating, he struggled to find a job and ended up working as a patent clerk in Bern, Switzerland. But this dead-end job turned out to be the perfect environment for deep thinking.
While reviewing patents, Einstein had time to develop some of his most revolutionary ideas, working tirelessly in the evenings to challenge the very foundations of physics. The year 1905 is known as Einstein's miracle year. He published 4 groundbreaking papers that revolutionized physics. Among them was his special theory of relativity, introducing the famous equation E equals mc squared.
That mass and energy are but different manifestations of the same thing. A somewhat unfamiliar conception for the average mind. Furthermore, the equation E is equal mc squared, in which energy is thought equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy, and vice versa. The mass and energy were in fact equivalent, according to the formula mentioned above. This was demonstrated by Kokra and Walton in 1932 experimentally.
And this equation showed that mass and energy are 2 sides of the same coin. It laid the foundation for nuclear energy, and unfortunately, nuclear weapons. In 1915, Einstein presented general relativity, a radical new way of understanding gravity. Instead of seeing it as a force, Einstein realized that massive objects bend space and time itself. When astronomers confirmed this during a solar eclipse in 1919, Einstein became an instant celebrity, the first modern science superstar. Now, Einstein's ideas changed physics, but there was one thing he never accepted: quantum mechanics. Einstein believed nature was deterministic, with his quote, "God does not play dice." Niels Bohr defended quantum uncertainty, where particles exist in multiple states until observed. Einstein, Podolsky, and Rosen proposed a thought experiment suggesting that quantum mechanics allows spooky action at a distance. Bohr argued that quantum entanglement is not illogical, but different from classical intuition. So the outcome of the debate is that Einstein never accepted quantum mechanics, while Bohr stood by his interpretation. Later experiments like Bell's theorem confirmed Bohr's view, and quantum mechanics remains the foundation of modern physics, powering lasers, transistors, and quantum computers today. As the Nazis rose to power, Einstein, as a Jewish scientist, fled to the United States in 1933. Through a pacifist, he co-signed a letter to President Roosevelt, warning that Nazi Germany might develop an atomic bomb.
This led to the Manhattan Project, the development of nuclear weapons. After the bombs were dropped on Hiroshima and Nagasaki, Einstein deeply regretted his role, spending the rest of his life advocating for world peace.
First record of the doom of Nagasaki, target for atom bomb number 2, is filmed from a superfortress many miles away. Beneath that sinister pall of smoke, the world's most destructive force has been unleashed, with what results we know only too well.
Einstein spent his later years in his Princeton office, trying to find a unified field theory, a theory that could connect all forces of the nature together.
Though he never completed it, his work continues to inspire scientists today.
We have gathered here in Princeton to serve the cause of the Hebrew University in Jerusalem. The university was founded long before the establishment of the independent state of Israel.
Einstein's formulas. This field equation. Theory of special relativity. Another field equation. Equation from his handbook. And the most important one, the mass energy formula. And lastly, this thing. This is Einstein's last home. It wasn't a mansion or a lab filled with machines. Just a small house, some quiet streets, and one of the greatest minds in history, still dreaming big. In his final years, Einstein remained at the Institute for Advanced Study in Princeton, walking the same paths, still driven by the mysteries of the universe. Albert Einstein died on April 18, 1955. His brain was preserved for scientific study, but his ashes were scattered in an undisclosed location, honoring his wish for privacy.
Einstein's theories are still shaping our world. They are used in GPS, black hole imaging, and even space travel. So what do you think? Was Einstein the greatest mind of all time? Let me know in the comments, and we'll see you next time.